Welcome to section 8.1 and 8.2 where we are going to apply exponent properties involving products and quotients. So let's just talk about an exponent is something like x squared. The squared is the exponent. Products is just another word for multiplication. And quotients is just another word for division. Okay, so let's just start. And I'm going to do a little bit with zooming in and out so you can read my exponents when we go. So I'm going to start with a cubed times a squared. And I know that a cubed is the same as a times a times a. And I know a squared is the same as a times a. So if I count at my a's, I have 1, 2, 3, 4, 5. I have a to the fifth. So far so good. But that's a lot of work to write the a's every single time. So what did I do? Really, I could just say 3 plus 2 is 5. So I have a to the 3 plus 2. And that's called product of powers property. So product of powers property. I don't really care if you can remember that it's product of powers. I just care that you can apply what the skill is. So what that says is when you multiply powers with the same base, you add the exponents. So I think the important words on here are multiply and add. So when you multiply, you add. An important other word is base, same base, and a base is like x squared. The square x is your base. The 2 is your exponent, and the x is your base. So let's just try one where we have 7 cubed times 7 to the fifth. If I can apply the rule, I know that that is just same as just 7 to the 3 plus 5, or 7 to the 8th. But let's say that we don't remember what the rule is, or we're stressed and we don't even know what our name is right now. We can do that in two ways. This is what I want as your answer, but we can get there two ways. So I have 7 times 7 times 7, which is the cubed, times 7, 2, 3, 4, 5. So I have the 5, so it's 7 to the 1, 2, 3, 4, 5, 6, 7, 8. 7 to the 8th. Awesome, but let's say we think we're right, but we're not 100% sure. Let's put in our calculator. 7 cubed, and to do this, you do this little button. It's called a caret. It goes up, cubed, times 7 and caret 5. To get it out of the exponent, you have to use this over arrow, and I'll show you that one more time. So 7 cubed. I don't want everything in the exponent, so I over arrow this button right here. 7 times 7 to the fifth. I get a massive number, 5764801, and I need to see if that's equal to 7 to the 8th, which is what I hope it does, because that's what I think it is. So 7 up caret 8. Oh, they match. That's awesome. So my check worked also. So this is the answer, but there's two ways to check it or to get to it if you're having difficulty. So that's the first one. Let's try another example. Negative 5 times negative 5 to the sixth. Oh no, I don't have an exponent here. But that's okay. If there's no exponent, I know there's an exponent of 1. So that equals negative 5 to the first times negative 5 to the sixth. And that's negative 5 to the 1 plus 6, which equals negative 5 to the seventh. And if you notice, it's really important. I kept my parentheses every time. Let's see what it looks like in my calculator if I do and if I don't. Negative 5 to the seventh, a negative number. No, it won't matter on this one. To the seventh, also a negative number. So in this case, it doesn't matter because my exponent's odd. But we'll get to that later. Sorry, I wasn't thinking. So x squared times x to the fourth. Last kind of example. So I know that's just x2 to the plus 4, x squared plus 4. So I know that's x to the 6th. I would like you to pause and try 3 more. You try. So I have 3 squared times 3 to the 7th, 5 times 5 to the 9th, and x squared times x to the 6th. So if you can pause, and we'll go from there. Okay, thanks for pausing. So I know my base is the same, so it's 3. So I have 2 plus 7 is 9. So I know my base is the same. I know this has a 1 right there. So 1 plus 9 is, 10. And here I have x. 2 plus 6 is 8. No. Yes, 2 plus 6 is 8. And I'm good to go. So far, so good. So let's do another page of notes. If you don't want to separate them based on property, that's fine. I just find it's an easier way to organize if I do it that way. So let's do our next one. If I have a squared cubed. So I know this means that I could write a squared times a squared times a squared. And if I use my product of powers rule, which we learned last time, means I just add the exponents, right? So that equals a to the 2, 4, 6. But that wasn't a lot of work, but it's more than I really want to write just for letters. So what does the 2, 3, and 6 have in common? Awesome, you multiply, so it's a to the 2 times 3. So this is called power of a power property. So power, and then it's of a power. So we have the power of the power. So we have power times with a power. And what this is when you have a power to a power, you multiply the exponents. So I have a power to a power, and then you multiply. And that's what's important here. So let's try one. I have 2 to the 5th cubed. And that is the same as 2 to the 5 times 3, because I multiply. So that is 2 to the 15th. So let's see what we get. So I have 2 to the 5th, enter, 32, cubed. 3, 2, 7, 6, 8 equals, and then 2 to the, not 25, 15. I get the same answer. So my numbers check out. So that truly is my answer. Awesome job. Okay, let's try another one. X squared to the 4th. So it's a power to a power. So I know it's just multiplied. So 2 times 4 equals x to the 8th. So far, so good. Now let's try a different one. Negative 6 squared to the 5th. So you might wonder why these brackets, and that's just because we don't like to use double parentheses because they get messy, confusing, and overwhelming. So I have the negative 6, which I'm going to keep in the parentheses, but it's a power to a power, so it's just going to be 2 times 5, and that is negative 6 to the 10th. So we saw last time that the negative didn't matter if I kept it in or not. Let's try it on this one. So I have negative 6 to the 10th is that answer. And then I'm going to try negative 6 to the 10th this way. And I get a different answer both times because it's an even exponent. But instead of having to remember if it's even or odd, just always keep it in the parentheses because sometimes it can become even or odd based on what you do the power to. So that's just a helpful hint. Okay, and then our last one, we haven't done these yet. So x plus y to the 6th squared. So that is, I'm just going to keep this in here because it's addition, so I'm not going to do anything with it. And then it's 6 times 2, which is x plus y to the 12th. And I'm done. I've solved all of them. So, same drill. I'm going to give you some ones for you to try. I never zoomed in. I'm sorry. So I'm going to give you some ones for you to try. So I have 4 squared to the 7th. negative 2 to the 4th to the 5th, n cubed to the 6th, m plus 1 to the 5th to the 4th. Sorry, pause and let's check them. Okay, thanks for pausing. So let's check. So I have 4 to the 2 times 7, so 14. Negative 2 to the 4 times 5, so 20. N to the 3 times 6, so 18. And m plus 1 to the 5 times 4, so that would also be 20. So far so good. Hope it's starting to make a little more sense. So let's go to page 3. Let's zoom out again. And we're good to go. So I have AB cubed. So I could write that as A times B, AB, AB. And then if I wanted to, I could group it A times A times A times B times B times B. So I get A 1, 2, 3, B 1, 2, 3. So I get that answer. But really, if I think about it and use my previous rule, these both have exponents of 1, right? So I use my product of powers. No, I use my power of a power property, and I go 1 times 3 is 3, 1 times 3 is 3. The important part is to remember that I have to do this exponent to everything in my parentheses, not just the numbers I find most, easy or most, however you would want to choose to which ones to do. So this is called power of a product rule. So if you look back at your notes, we had m plus 1 20th. It's not m to the 20th, 1 to the 20th, because this is separated by addition. This is saying product, so they can only be separated by, yes, multiplication. So let's write what that is. To find the power of a product, find the power of each factor. So that's basically your A and B here, and then and multiply. And we're not going to do anything else with that. A cubed times B cubed is as simple as we can get it, so we're done. But if we could do something more, we would. So let's take a look and do some stuff with actual numbers. So I have 24 times 13 to the 8th, and I want to simplify this. So this is a power of 1, this is a power of 1. So I have 24 to the 8th times 13 to the 8th. And I'm just going to let you know these numbers are huge. So I have open parenthesis 24 times 13 to the 8th. Whoa, this E means times 10 to the 19th. So that's a really big number. I don't want to write it down, so I'm just going to write big number. And then 24 to the 8th, and we need to remember to use this down arrow or over arrow to get out of the exponent, times 13 to the 8th. And those match, so same big number. So my check works, so this is my answer. So far so good, hopefully. Okay, so now let's try another one. 9xy all squared. So I have to do each thing, even though these all have exponents of 1. I have 9 squared, x squared, y squared. I just put the 2 for each one, and since they all have exponents of 1, I don't even have to think about it that hard. Okay, so let's look at our next. Oh, that's it. So now I'm going to have you try. Okay, so I have 3xyz to the 4th. Pause and do it. Thank you. Okay, so you should have had 3 to the 4th, x to the 4th, y to the 4th, and z to the 4th. And that is my answer. Okay, so now we're going to try all 3 rules. So to try all three rules, let's start with something. So I have 2x cubed times x to the fourth. So the first thing I'm going to do is I'm going to do the power of a product rule. So I'm going to get this 3 out. So it's 2 cubed times x. It's a power of a power, so it's going to be times x to the fourth. So then I'm going to take it again. So 2 cubed times x to the 9. It's 3 times 3, not plus, times x to the fourth. And now I'm going to do, I have the same bases, so I'm going to go 2 cubed times x to the 9 plus 4. So I have 2 cubed times x to the 13th. So that's a lot of steps, but I really would recommend at least doing most of them. This step right here where you show me its multiplication and this step right here where you show me its addition, you don't have to do, but I need the other two steps to be shown, just so you can make sure that you're doing it right and not losing points for something that's easy. So let's look at, I want you to try one now. I want you to try x squared y all squared times 2x cubed times y cubed. Okay, pause and go. If you get stuck, make sure you play so that I can show you how to do it. Okay, thanks for pausing. If you didn't pause because you thought it was too hard, that's okay too. So I'm going to get rid of this exponent on the outside. So I have x to power to a power, so it's 2 times 2. And the y is just the y1, so that would just be a 2, times 2 cubed, power of a product rule, x cubed, and then I just keep the y cubed there. Okay, so I'm going to do the step where I just do my multiplication. So x to the fourth, y squared times 2 cubed, x cubed, y. So I've run out of room, so I'm just going to take my next step over here. And this is a step that can be somewhat confusing, but all I'm doing is rearranging them so that they're in a more logical order for me to deal with. So I'm starting from left to right in my first number, 2 cubed. Okay, no other 2's, no other numbers, so now I'm starting over here. I get x to the fourth, so I get that. My next x is x cubed, get that, and no other x's, so then I have y squared, this is a cubed, and then times y cubed. The 2 and the x to the cubed are not connected. Everything in multiplication can be rearranged, so that's all I did. So I have 2 cubed, because that's just copying us. So I have x to the fourth times x cubed. So I have x to the 4 plus 3. And y to the squared cubed, so 2 plus 3. So I have 2 cubed x to the 7th, y to the 5. And that's my answer. And if you didn't want to show all the steps, this step right here is a good one to skip. And this step right here is a good one to skip. I would recommend reordering it just so you don't make sure you don't lose anything, especially in the first steps of doing it. Okay, we're on page 3, so now we are on to page 4. So let's start. So now we're going to get to division. So I have a to the 5th over a cubed. So I could rewrite this as 5a's, 1, 2, 3, 4, 5, over 3a's, 1, 2, 3. And this is something that, remember, we get a cancel, so let's use some sound effects. Loop, loop, loop. So those are gone. So all I have left is the 2a's that are being multiplied on top. So that is really a squared. But that wasn't that much work, but it's more than I really want to put forward if I can do it in an easier way. So I see 5, 3, and 2. I see that 5 minus 3 is 2. So I have a to the 5 minus 2. And that's my, or 8 minus 3, because this is a 3. And that gives me my a to the 2nd. So this is called the quotient of powers property. So what this says is, it says to divide powers having the same base, and same base is important again, subtract exponents. This won't work if they're not the same base, so when we divide, we subtract. When we multiplied, we added. So they're kind of, you know, reverse operations of each other, and we'd use the reverse operation. Okay, so let's try one. So I have 8 to the 10 over 8 to the 4. So I know when I'm dividing, I subtract. So I know that's 8 to the 10 minus 4 equals 8 to the 6th. So far, so good. And I'm going to put this in the calculator and see if I get that same answer. So 8 to the 10th. That's quite nice. And I'm going to go divided by, in parentheses, 8 to the 4. Oops, I forgot to get out of there by pushing this button right there. Okay, so I have 2, 6, 2, 1, 4, 4. Let's see what 8 to the 6th is. Yes, score, same answer. So that's 2, 6, 2, 1, 4, 4. So my check worked, and that is my answer. So let's try another one. So I have negative 3 to the 9 over negative 3 cubed. So I know it's division, so that means I subtract. So I have negative 3 to the 9 minus 3 equals negative 3 to the 6th. And I'm done. And if I want to check, I can, but I don't have to. I just wanted to check so that you knew I wasn't pulling your leg. So let's do one more, or two more. So 1 over x to the 4th times x to the 6th. I'm going to rewrite it as one fraction. You can or cannot, it's your choice, but I have x to the 6th over x to the 4th. It's division, so I know I subtract. So it's x to the 6th minus 4 equals x squared. And I'm done. So last one that we're doing as an example on this page is 5 to the 4th times 5 to the 8th over 5 to the 7th. So this one we're having to apply the product of powers property and the quotient of products property. Powers. Quotient of powers property and product. We're multiplying and dividing. So I'm going to multiply first. So I have 5 to the 4 plus 8 over 5 to the 7th. And that equals 5 to the 12th over 5 to the 7th. And then I get 5 to the 12th minus 7. So I get 5 to the 5. And that is not 1. That is a much bigger number. So I have 5 to the 5, 3125. But this is the answer I want, not 3125. So far so good. So I want you to try 6 to the 11 over 6 to the 5. And negative 4 to the 9th over negative 4 squared. And then last, 9 to the 4th times 9 cubed divided by 9 squared. So I want you to pause and solve. So thanks for pausing. I hope that you got 6 to the 6th, because 11 minus 5 is 6. I hope you got negative 4 to the 7, because 9 minus 2 is 7. And this one, the last one, I'm going to do into the 2 steps. So I have 9 to the 7th over 9 squared. And then I'm going to do, because it's 4 plus 3. And then I have 9 to the 5th, because it's 7 minus 2. So I hope that worked for you. If not, it's okay. Maybe look at what you did and what I did differently, and then we can see how to make that right. So last property for today is one where we go a divided by b to the 4th. So I could rewrite that as a over b to the a over b, a over b, a over b. And that is a to the 1, 2, 3, 4, a to the 4th, and b 1, 2, 3, 4, b to the 4th. So this is very similar to what we did with the power of products rule, where we just can say that it's the 1. We know it's the 1. So it's just 1 times 4 and 1 times 4. But we just have to make sure that we do it to every letter in the parentheses. So this is called power of quotient property. And the definition of that is to find the power of a quotient, find the power of the numerator, and the power of the denominator, and divide. And we don't always have to divide, because this one is as divided as we can get. So let's just do a couple quick examples. So I have x over y cubed, and that is just x cubed over y cubed. Just because those are 1s, so that's it. So let's try one more. Negative 7 over x to the 4th. So it's negative 7 to the 4th over x to the 4th. As long as I remember to put it for every term, I'm done. So I would like you to try. So a over b squared and negative 5 over y cubed. So pause and try. Okay, thank you for pausing and trying. So hopefully you got a squared over b squared and negative 5 cubed over y cubed. Hopefully that's what you got. So now I want you to try one where we're combining all the pieces we've learned. So I have 2x cubed over 3y. Oops, 2x over 3y all cubed times y to the 5th times x over 1 all squared. So pause and try. If you feel overwhelmed or can't do it, just watch me do it. Okay, hopefully you paused. If not, that's okay. So I'm going to distribute my 3, because it's 2 cubed x cubed over 3 cubed y cubed. And instead of doing a second, I'm just going to extend my division line. So I have y to the 5 times 2, it's a power to a power, so it's y to the 10th over x squared. And I don't need to rewrite my 1. So now I'm not going to do anything with my numbers because they have different bases. But I have x cubed times x squared. So I need to add those exponents, so it's x to the 5th. And then I have y to the 10th divided by y cubed, which would just be subtraction, so 10 minus 3 is y to the 7th. And that is all the concepts we've learned today. So thank you for paying attention. Hopefully you solve that on your own. If not, it's okay. You have plenty of homework to try it on. So thank you. Bye.